Okay, students, this is part 2 of proving lines parallel. I showed you what you need to show in the last video, but now I'm going to do it with examples. Okay, so when you see your review, we're going to stop right here for our unit, and I'm going to give you a review packet tomorrow. And so anyway, here's examples of how you do it if you saw one of these in your review packet. And then on the following pages, I'm going to review your different types of lines. Angles given parallel lines cut by transversal, how to identify them correctly, name them correctly on following pages here. So this is review. Nothing new. It just has some specific examples in here that I'm going through for this video series here today. All right. So if they're asking us to tell whether lines M and M are parallel given these pieces of information here, each one separate. So it says if angle 7 is congruent to angle 3, I put these in here already. If those two are congruent, can we say M and N are parallel? And the answer is yes, because these are alternate interior angles. If we know if alternate interior angles are equal, then the two lines are parallel. So yes, by the converse of, remember whenever we're trying to prove lines parallel, it must be converse of the AIA theorem, or whatever type of angles they are. These happen to be alternate interior angles. In some books, like in our packet that we'll look over tomorrow, they put the converse on the end. It doesn't matter, it's going to have the word converse in it. That's the key. Okay, so the question is, how do I know it's lines M and M that are parallel and not P and Q that are parallel? Very simple. Watch this. So if I draw my two arcs in here, they aren't normally drawn there. Go ahead and draw them in yourself when you're looking at each one of these. Notice this arc touches this line and this arc touches this line. So in the two arcs, each arc touches one line. That's always your transversal. The other line that each arc touches, so it touches right there on M and it touches right here on N, that's the two lines that are parallel. Okay, so the ones that touch only once, they're the parallel lines. The one where the arcs touch twice, that's your transversal, if they ever ask you that. The reason I say that, because that is a part type question that you will be getting, and we'll practice on that later. Okay, but that's how you know which pairs of lines. So notice when I draw the two arcs, there's only one that's touching line P here. Okay, there's nothing touching line Q. Neither of these arcs is touching line Q, so it can't be P and Q that are parallel. They're both touching M, N, and P. So these are my parallel lines. Okay. All right. Number 2. If angle 3, given, what do we have to know about angles 3 and 1? 3 and 1, let me get rid of this here. 3 and 1 are right here and right here. I should know those are corresponding angles already. I know corresponding angles must be equal if these are going to be parallel. So that means when I plug in 8 into here and plug in 8 into here, I better get the exact same answer in order for these to be parallel. When I do get 142 and 142, so therefore M and N are parallel. Okay, so yes, converse of the corresponding angles postulate, because they're corresponding angles. Number 3, 7 is congruent to 6. Well, if I look at 7 and 6 here, I should know those are called same side interior angles, or consecutive interior angles, or just consecutive angles. Okay. They have to be supplementary. Remember, same side starts with S, so they must be supplementary, which means they must add to 180. This says they're equal, so the answer is automatically no. They must add to 180. Okay. Number 4, angles 2 and 3. What has to be true about 2 and 3? Well, they're same side interior angles again. So again, they must add to 180. So now they give you a number, plug it in here, plug it in here. When I do it, I get 73 and 107. When I add those together, I do get 180. So now these two lines, M and N, are parallel by the converse of the same side interior angles theorem, or consecutive angles theorem. Okay. Number 5, angles 8 and 4. Okay, so look at 8 and 4. 8 and 4, those are called exterior angles. You should know that. And we know exterior angles must be equal. So plug in 9 in here, 53 and 48, those are not equal, so the answer is no. How about angles 5 and 7? 5 and 7, those are corresponding angles. Corresponding angles must be congruent or equal in order for the lines to be parallel. So if they're congruent, yes, they will be parallel. M and N will be parallel by the converse of the corresponding angles postulate. The corresponding angles postulate or theorem. Okay, some books will say corresponding angles theorem, others say corresponding angles postulate. I'll take either one. keyword, you're going to see corresponding angles, converse of and corresponding angles. Number 7, 1 and 5. 1 and 5, what kind of angles are these? Alternate exterior angles. So they again must be equal. And it says they are congruent, which means they will be equal. So therefore the answer is yes by the converse of the AEA, alternate exterior angles theorem. And lastly, angles 6 and 2. What has to be true about 6 and 2? Those are alternate interior angles, so they must be equal. So notice they don't give me a value to plug in, you know, an x value to plug in like I had in here or here, okay, or here. So it means I must set those equal to each other and solve. When I said x plus 10 equal to x plus 15, I get 0, x equals 5. That can't happen. So they'll never be equal. So the answer is no in this case. Okay, so these are specific examples on how to determine whether two lines are parallel or not. If they are, it's always going to start with converse of and then whatever type of angle pair they are. Okay, next I wanted to show you a type of problem that we haven't seen yet in our packet on our angle measures, but you'll see and can see on the part. If they give you this type of drawing right here, and they call this angle right here y, and they want you to find that angle measure. Okay, well, that may look confusing. So what we do is we draw an auxiliary line parallel to the other two parallel lines right here. These are parallel. We're going to draw an auxiliary line. So I'm going to go ahead and pull this in right here, and this is now I'm drawing that in there, and now that's parallel to that. And the reason I'm going to do that is because now I have parallel lines cut by transversal here. So I have alternate interior angles are equal. So if that's 50, that puts a 50 right there. Okay. And I have the same thing on the other side. Parallel lines cut by this transversal. So alternate interior angles are equal. So that puts a 45 right there. Okay. And so now I can get the whole angle of angle Y by adding these together, and I get 95 degrees is what that is. And sure, you could think, oh, I just got to add these together. But the reason I want to show you this is they might have you explain this in words like in a box, which means like, you know, explaining your steps, which means you have to state, I'm going to draw an auxiliary line parallel to the other two. Okay. And then talk about parallel lines cut by transversal, alternate interior angles are equal. You know, you could call this like, you know, X and Z if you wanted to when you're describing an angle X, angle Z. Okay, to make it simpler and clearer. And we have parallel lines cut by transversal down here, and alternate interior angles are equal. Okay, and then I add them together. That's what your whole explanation would be in a box. Okay, if you had that. Okay, so now we're going to just review our types of angles, what they're called, and we have parallel lines cut by transversal. And I have examples there. A and B. A and B, we should know those are called vertical angles. Okay, G and F, we should know that forms a linear pair. And you should remember that linear pair theorem says if two angles are linear pair, then they are supplementary, which means they add to 180. There have to be adjacent angles as well, which they are for a linear pair, and only two of them. H and F. H and F is also a linear pair. Okay, which means they're supplementary, which means they add to 180. E and G is also a linear pair. They're just randomly generated like this, but we'll practice others in class. And lastly, E and F, vertical angles right here. Okay, so you only have two types in this particular randomly generated one. Okay, let's fill in this down here, whether they are congruent or supplementary. A and D. A and D form a linear pair, so they are supplementary. G and D. G and D are alternate interior angles, so we know alternate interior angles are congruent. H and G. H and G are vertical angles, which means they are congruent. E and A. E and A are corresponding angles, which means they are congruent. And F and B. F and B are corresponding angles, which means they are congruent. Okay, so we end up having a lot of congruent ones here, and only one supplementary in this randomly generated one. Okay, all right, 11 here. A and C. What do I know is true about A and C? They form a linear pair, which means they're supplementary, which means they add to 180. So I take that angle plus the bottom angle, and I know they must add up to 180 degrees. So I combine those like terms. They have to add to 180, those two angles. Okay, so here we get 8x and minus 37. Oops. 8x minus 37 equals 180, so I add 37 across. So I have 8x equals 217, and divide by 8 on both sides. I get x equals 217 over 8. That doesn't come out nicely, so it's just a fraction right there. More likely, if you see it on a normal practice sheet or test, it'll come out nicely, or park. All right, G and C, how are they related? G and C, they are corresponding, so that means they are congruent or equal. So now I set each one of these equal to each other, so I can put an equal sign right there, and then just bring up this right here, and I have x plus 20. And I'm solving that. How do I solve that? Bring the smaller coefficient over the big one, so subtract 1x across, and I get 4x. That means I am adding the 37 across. So 37 and 20 is 57. Again, when I go ahead and solve that and divide by 4, I get x equals 57 over 4. That does not simplify, so I can just leave it right there. And that would be my answer. Okay, so there's more examples. Let me see if I did it. Yes, here. Okay, so name a second angle to make the statement true. We want a linear pair to angle HGB. So this is making sure that you know how to identify where these angles are and how to name another angle correctly with 3 letters. 3 letters, never 1. Always use 3. HGB right here. If you want to, you can draw it in right there. We want a linear pair. Well, a linear pair is adjacent and forms a line. So I can use this angle, forming that line, or I can use this angle, forming this line. Your choice. Just says name a second angle. So if we want to name that angle, EGB, it would be to name that angle, EGB, or don't forget I could have gone BGE, and that would be this one right here. Okay, so that's that one. Now let's go ahead and look at this one. Adjacent, remember adjacent means next to angle ABC. ABC, there's ABC. If you can't identify where ABC is, you're in trouble. You can't do any of these problems. Adjacent means next to, not across, that's vertical. So it's either this angle, it's adjacent to it, or this angle, your choice. Let's say we go with that one. Then we're going to call it GBC or CBG. I could have used F, but I don't have to. I just chose the closest one. GBC, we'll call it. Okay. Corresponding to angle. Let me erase that there now. Okay. Corresponding to angle CBG. CBG. I gotta be able to name that angle correctly. CBG. Where's the corresponding angle? There's only one right down here. That's the interior angle. So we need the exterior angle. It's on the same side of the transversal. So how do we name this? Now see how they call this CBG? Then we want to name it in its what's called corresponding order. Because they chose to do this one first, then it went down, we're going to do the same thing. Go here and then down. So we're going to call it HGF. That's called naming it in corresponding order. So get used to that because we're going to have to start doing that all the time coming up. I'm just showing you right now that's called corresponding order. Even though FGH is the same angle, that would not be in the corresponding order. The corresponding order of FGH would be GBC. Okay, if you want to just know that. All right, so let's erase that one. And let's go to the alternate interior angle of EGB, this angle right here. EGB, the alternate interior angle, we should know is that one right there. So again, if we're going to go in corresponding order, they started on the outside, came in and went up. We're going outside, in, and down. Okay, so we're going to call it CBG. It'll be in corresponding order. CBG. Okay, now we want the alternate exterior angle of angle ABC. Where's ABC? You gotta know where that is. ABC right there. Remember, the middle letter is always your vertex. Called the vertex. So what is the alternate exterior angle of this one? This one right down here. Okay. Notice they went ABC, so the opposite of A down here is F. So it's going to be FGE is our corresponding order for that one right there. FGE. Even though EGF is the same angle. Okay, they didn't start on the side, they started on the top down here, so we're going to start down here. FGE, corresponding order, that's called. Same side interior angle to DBG. Okay, let's erase that first. Okay, so now we have DBG. DBG right here. This angle. What is the same side? Obviously, it's got to be on the same side. So it's one of these here, that one, that one, or that one. Interior. It's got to be an interior angle. The only other one is this one right here. Okay. Notice I put two arcs there because they're not congruent. We know same size. There's an S, so they are supplementary. You should be reviewing that in your head. They have to add, these two angles have to add to 180. But anyway, they just want the other angle. They want this angle. So what is the order they put in? They said DBG. So we're going to go EGB. Okay. EGB, corresponding order right there. Notice I remind you it's also called consecutive interior angles or consecutive angles. I think they should have the word consecutive interior angles. All right, so last one, we want a vertical angle. That should be nice and easy. A vertical angle of angle FGH. So where's FGH? FGH right here. What's this vertical angle? There's only one right there. Okay, so FGH, we'll go ahead and call it BGE. BGE. Okay, and so there's the ways that we name the angles correctly with 3 letters each time in practicing your different types of angles that we have here. All right, that ends all this review. This will all help you when you're doing your review packet for your upcoming test. See you in class tomorrow.